Hello and welcome back to Cipheros. These are all the Python building functions. Now we must understand first a very basic definition of function, not only in Python but in mathematics, in programming in general. Basically, what I want to picture out for you, okay, on a simple definition and understandable, would be that a function works like a magic box. If we set something, in this case an X, this magic box will execute a process and then it will return a Y. So this X changed to a Y. So if we apply something to X, we're going to have Y. Let's say a very basic function. If we have that f of x is equal to x plus y, it means that no matter what x we set, we're going to add that number by 1. If my x is 2, if I apply this function, 2 plus 1 is 3, and so on and so on. Obviously, functions are not limited to that. We can do basically anything with any number. So my function doesn't have to be x plus 1, but it can be the logarithm of x divided by 2, the integral of x, okay, or the derivative of the summation of x, or the factorial of x. You get the point. In programming, the thing doesn't change that much, but we have more flexibility. I mean, in Python specifically, we have this syntax for defining a function. Notice the ident lines. We simply declare def, the name of the function, it doesn't matter, the args, the number of args. In this case, we have just one. And then we do something with the code, not necessarily with the args, and also optional returning a value. If you want to interpret this return, will be just like throwing the Y, same way as the picture shown. So let's get into all the building Python functions. By the way, building functions are just functions already declared in Python, because as you know, Python is built in C++. So all the code written in Python is translated into C++ to then be executed. All the functions that we are going to see are translated into the already declared functions in C++. So let's get started. The first one is the well-known print, which just prints objects to the text stream, abs, and it stands for absolute value, okay, of a number, rather than the method, okay. We have an example of how this works. Next, we have all, and it takes an iterable. So what does it returns true if all the elements of this iterable are truthy, but false if there is at least one that isn't. On this case, we have the iterable 1 and iterable 2. As we can see, 2, 10, and a string, not empty string, are truthy values. So these are interpreted as true. Yet at the iterable number 2, we have a 0, and 0 is a falsy value. Any number different to 0 is truthy. Similarly with any, it returns true if at least one element is truthy. Getting back to that code, well, we see that, yeah, they accomplish with the truthiness. Next, we have bin. So it converts an integer to binary with this prefix, by the way, just to identify that, yep, the conversion was done. Next, we have this function that takes an object and it returns a string with the special characters that constructed. So this E, as stated, will be interpreted as this. Next, we have bool, that stands for boolean, and it turns into a boolean depending on the argument's truthness. -5 is true as it's a non-zero value, while as explained you before, 0 is a false value, therefore it returns false. Next, breakpoint, and what it does, it just opens the debugger at that line. Where it is placed, following the sequence of the code, well, it will open the debugger. Next, byte array, and it takes as source and encoding as parameters. So it returns a byte array string, mutable sequence of bytes. Normally we can rewrite them or declare them within this b before the string. Similarly, we have bytes, which takes also the same parameters, and it returns a byte string. The only difference is that, yep, on this case, these are objects rather than a specific data type. And as you can notice, the encoding parameter is optional. It means that we can write it or not. Well, it doesn't matter exactly. Next, we have callable. It returns a boolean depending if the object can be used or called. Is this callable? Yep, and it returns true. Now with character, okay, I'm taking x as a parameter, it returns the unique code of an integer x. And if you don't know it, the alphabet, both lowercase and uppercase, are one of the first Unicode characters, and that's why if we said 67, we return an uppercase C. For example, if I would set 66, it would return a uppercase B. And yep, there are a lot of Unicode characters. As you can see, we have this emoji that takes this number. Next, we have compile, and it turns a string into a usable code. Let's say this print Cipheros revolution will be used as normally we write code on Python, okay, on the code editor. Yet the second parameter is the type of which our code will be turned into. Next we have complex that takes the real and imaginary values. So if you don't know what is a complex number, basically it is the definition of an imaginary number and everything just before the I, it's actually called iota, is just a coefficient. In this case, it's not represented in Python as I, but as j. And as you can see, the complex function just declares the real value and the coefficient of the imaginary value. Next, we have get attribute. And what it does is returns the value of a name attribute of an object. Here you have example. The only attribute that this class has is legs, okay, for a biped animal. And if we initialize on a variable this class and we check for legs, okay, we're going to have what this variable is assigned. In this case, a biped animal will have 2 legs, but there is no sports attribute. Therefore, we can set the default response, by the way, if it's not found. Here you have example. Something similar works with delete attribute, and it does what its name says. Next, we have dic, that stands from dictionary, and the arguments are the key value pairs as args. So what it does is just creates a dictionary. Next, dir, and it returns the value properties. Let's say we have a class for glasses, and for now we don't have the shape defined. We set this command. Therefore, the only value that is valid is color. About deep mode, that takes x and y as parameter, what this does is just returning a tuple containing both the exact division of x and y, that is turned into an integer, and the mode. Here you have some examples. By the way, the modulus will be always positive if you apply the definition of formula for modulus. Enumerate takes an object, basically it does the indexing work, okay? It index an object with the key value pairs. Yet if we want to take this result, we must turn the enumerate declaration into a dictionary, because if not, it just returns a process of completion. What does evaluate, which takes a string as parameter, it executes what is inside of the string. In this case, we have this example, which is very similar to compile, but simpler. Next, we have execute, and it takes a string. Same thing, but doesn't save the value. Filter is one of the most useful functions in real life for Python coding, and what it does is just filters the elements rules given by a function. You can see we have a list of 3 dishes, and we are using a lambda function because of its simplicity to find the foods that have a strawberry on their name. Next, we turn this into a list, because if not, it just will return the message of completion. What does float is converts a number or a string to a float, which is a number with decimals. Here you have the example. Overall, look up the 1. Well, next with frozen set, which is not that useful actually in real life, but it does is returns an immutable frozen set object. So we create our set, which is completely immutable. We cannot do the set methods that we are going to see next. Or you have seen on the previous video about all the building methods in Python. Next, we have format, which takes a value and a format is specified. It just turns into what we want. Therefore, if this 17 has this x as second parameter, well, it will return as hexadecimal. Same thing with 10, but with O, which is turned into octal. And if we set the number and F, well, it will be rounded into the number of decimals that we've specified. Hash, and it returns the hash value of the object. Okay, do you remember breakpoint? Well, we have a function very similar, which opens up the building help system. So on this line, because I've passed a str or a string as argument, it will show the string documentation depending on the sequence of the code. Continuing, we have id. It takes an object as parameter and it turns the memory view of the object, which can vary. It is almost unique from each computer and case specifically. Here you have some examples. Now, if you remind format, okay, on this case we have a specific function to turn it to hexadecimal. So this is what hex does. Keep in mind the 0 and x. just to identify this number as hexadecimal. Int, it just runs the number to the nearest entity. Also, it turns a string into a number, by the way. Next, the well-known input, okay, and it just takes a prompt. Basically, what it does is that it returns what has been written on the prompt. That's all. It's just a getter on the code. Next, we have len, which is just an abbreviation of length, by the way, and it takes an object as parameter. As you can see, it returns the length of an object. By the way, no, the index is known from 0 on this case. So this hello, which is a string, has 5 elements. Similarly, with this array, it has 3 elements. This case is very different to the way we use indexing, which comes from 0. Next, we have list, takes an iterable and it just creates a list. In this case, we have and the string can be also done into a list. Next, we have map, and what it does, it applies the function on each element of the iterable. So it takes a function and then iterable where the function will be applied. On this case, we have this list, and what we're going to do with it will be just squaring each number, always listing if we want to get this exact result, because if not, it will also log just a completion. Next, we have max and min, which are very similar and just return the max and min value of an iterable respectively. Memory view, and it takes an object. It returns a memory view and notice the B, which stands for byte array. This is more using computer science than programming in general. Next, we have object, and it just creates a filters object. That is all. It is very useful for things that on the future will be updated. Next, we have octal, and it just turns a decimal base into octal. Here you have the examples. Notice the 0 in prefix. Okay, the X on this case is for any number. That means the octal equivalent. Considering we have open, and it takes a 5 parameter and mode. This reloads means in this case that we have more parameters, okay, but we consider that these are the most important ones and useful for real life. What it does is just opens as file with the selected mode. These are the 3 principal ones. R, that stands for read, W, that stands for write, and A, that stands for append. So the first parameter is the directory of the file, and the second one will be the mode that we open. Next, we have PO. So what it does is basically executing modular exponentiation, which is a mathematical process. Normally, the modulus can be very omitted. Range, and generates a sequence of numbers. The stop value is not included, by the way. So if I set range 4, I will have 1, 2, 3, but not around the 4. And by the way, it doesn't count to 0. If we take the start and end parameter, well, we're going to start by the first one, but we will not arrive exactly to the second one. Similarly, if we take that third parameter, which is the step, well, we're just performing the sequence as with parameter, this function that I don't know how to pronounce. And what it does is returning a representation, well, a string representation of the object. We have text, Cipheros. We see only just the difference between the double quotation marks and the single quotation marks, yet because I actually apply this on a string. But for example, if this text will be just a number, then let's say if we pass this variable into rep, we're going to have, yep, a normal 10. But if we take the type of it, we're going to see that it's just a string, even if the number doesn't have quotation mark. Round, and it takes a number as parameter. It just returns the number rounded to the end digit. Here you have the example to the first 3 decimals. Set, and it creates a set which are unordered, by the way. So this example is not the only one. I mean, this set could be your own love Cipheros X, but on another case, this could be mom loves your Cipheros. We have these parameters, and it adds the attribute to the object. Here you have some example with the Cipheros class. We can update these attributes with this built-in function. We are almost on the end. We have a slice. Notice how the double dots indicates to which value we are approaching. So if it's before a number, this would be all the elements until that specific index. But if we have a rightward to the value, we're going to have all the elements until the end, starting from that value. You have also some examples about how the range works. And let's continue with sort. which takes an iterable and key and reverse. Reverse is a Boolean value, by the way, and it just performs also the reverse built-in function. And it returns a certain list considering the alphanumeric indexing. So we're going to have all order based from the alphabet. Sum, and it returns just like perform summation, okay, from an iterable. It's not that complicated. So all these numbers will be added together. Yep, there's the step parameter. We don't have to specify the parameter because it just takes two parameters. And the first one is obviously the iterable. That is basically all. We start from 10, or basically all the elements that were added will be added to 10. We're very almost there. We have type, and it just returns the type of the object. Let's say we have this string, and basically it returns this message, class string. If it's a number, class number. If it's a boolean, class boolean. Similarly, we have a subvert, which allows method calls to a parent. Notice how the parent is passed as an argument from the child class. Both have their own methods, but with super, we can use the method for the parent on the child itself. In this case, we are just appending the file that is always being returned from the parent to the message on the child string, and it takes an object. It returns a string version of the object, by the way, which is very similar to rep or representation. There is not that much difference. Next, we have tuple. Intuitively, we may think that it creates a tuple because often use it for update. Almost finishing, we have bars, and it returns the past arguments on the constructor. If we have a class, as you can see that is initialized with name and level. Okay, we're going to have this call with backend and pro, and if we bring this call with the bars function, we're going to have name, backend, and level pro. Iterables also combines multiple iterables to tuples. So the zero index from the list 1 and 2 will be a new tuple, and so on until they cannot be matched. And it takes name principally. There are several parameters which I represented with these three dots. Principally, the most important one is name, and it's another way to input modules and libraries. These two group of two lines are the same thing. Methods and functions are not exactly the same thing, but methods are functions inside of a class which are exclusive for its instances. Data structures that barely want in Python are instances of a class which are in the code of Python. Do you remember that Python is made of C++? Well, on that C++ code, there are definitions that when we declare, for example, a specific data structure, these are initialized. In this case, I have a list. If I write this code, an instance of the list class is being run, and now I can use all the methods I want that there are on this class. On this case, for example, we have reverse, and what it does is just applying a mirror effect on the list. In Python, there are 4 building data structures, but I wanted also to extract strings from lists because they have their exclusive method. Notice that in the dictionary we have key value pairs, therefore this data is linked. Similarly, on set there is no pair, and on the tuple, notice how we use parentheses to declare it. So let's start with the matter. We're going to move on the string methods. So if we declare a string just like this, we can apply the next building methods. And the first one is upper. So what it does is turns all the characters into uppers. Similarly, with lower, we're going to turn all the characters into lowercase. With a strip, we remove leading and trailing white space. So there's no more blank space at the beginning or the end of the string. That's why I declare it like that to show it up. On a split, we turn the string into a list based on a separator. It takes a parameter. So depending on the separator, if it identifies, well, the next character will be the next element. Next, replace. Take a word or a character, the first instance of it, replace it with the second parameter. Very fast example. On file, well, it returns the first occurrence of what we are trying to find on the parameter, and here you have it. Yep, the blank spaces count for this research. About joining, we are turning a list or an iterable in general, but here you have the example, okay, into a string. Now let's move on to lists, which are very similar. So if we declare a list just like this one, we can use the next methods, just like append. And if you come from JavaScript, well, it works in the same way than the push method. So what it does is just adds the parameter at the end, which is basically the meaning of append, by the way. Next, extend. And it takes an iterable. Add all elements of an iterable to the list. Here's the relation that I explained to you, which was that, yep, strings are lists. So if you pass a string, it's taken as an iterable, well, we add each character as new elements. Next, pop. And what it does, it just throws up the parameter x. Therefore, if we bring out this list pop 1 on the console, it will appear Barbie. Yeah. About removing, which is also used in sets, by the way, this is not exclusive from lists. It removes the first occurrence of x. Now with sort, basically what does is just sorting the list in place of alphanumerically. Here you have the example. Notice that ABC and ADB share the first letter. We move on to the second one to compare. And if, for example, this share also B, we move on to the next one and so on. With reverse, we've already seen how does it work. Yet you have here another example. And let's move on to dictionaries. So if we have something like this, we can apply the next methods. And the first one is keys, which just returns all the keys. That is all. Similarly, with values, we return all the values that are found on the dictionary. Here you have the example. Next, on items, well, it returns all the key value pairs, as you can see over here. Notice that this is an array of tuples, by the way. On get, which takes a parameter, we are trying to find the values from a key. We can take as second parameter in this case, which is going to be a message if this value is not found. And around the last one, which is update and takes another dictionary, well, it takes the dictionary with key value pairs from another dictionary. If we declare another one that, as you can see, shares the same first key, which is vowel 1, but with a different value, which is new string 1. And if we apply this method, we notice that the value 1, which is the first key and the both share, is updated with the value of the second one, which is new string. Additionally, the x key and the value x, we have it are updated and added because the first dictionary didn't have it, but the second one. Let's move on to sets. So if we declare a set just like this, we can pass building methods such as the next ones. We have adds x to the set, very similar to append. I think this is the same thing. Notice that we can also add a tuple as a new element. Also, we have union, which takes an iterable, and what it does, it is just unifying the set taken as a parameter with the set applied. Something similar happens with intersection. This just returns a new set considering the values that set 1 and set 2 share. On this case, these two just share the number 1, and this calls will return this 1. Finally, we're going to move into tuples, and what we need to know is that tuples are immutable. Therefore, we cannot just do many stuff with them. Actually, the methods that we see are just for getting data. First one is count, which counts how many times the element appears on the tuple. On this case, we have 2 number ones. Finally, index takes the value, the start and in as parameters. Let's see, it returns the index where the element is found. So we have the subscribe in a string, and it returns just the number 2 because this one occupies the 0 index, this hello occupies the 1 index, and this 2, well, this is what it returns. Yet, if we pass the stat and end parameters, which don't have necessarily go along, this process could change completely. Let's say subscribe and then 3. So with a start, our process of searching from these 3 elements, and because there ain't nothing else right words, well, it just verifies over here, but obviously it is not. Okay, one is not subscribed. Basically, they pass a function as the argument of another one. This is the syntax. To declare the call of a decorator, we use the @ symbol and the name of the decorator above the definition of a function. This is the same exact thing that passing that function onto that decorator. Now we're going to have a simple approach so you can understand it. First, we define our decorator as a function, like we normally do. On this case, we're going to square a number. So we pass this parameter func can be anything, any name, do not worry about that, but what is needed is this wrapper. Okay. The wrapper is also a convention, but I think it's we must declare a function inside of this square one. Now this line is basically what does the function, therefore we just pass this argument with parentheses. If not, it will be not read as a function, and then we square this. So what returns this function will be a square, and then we return this wrapper. So once we declare this basic function that just returns a 10 number no matter what happens, this will be passed into this square one. So this is how decorators work. Another example, a little bit more complicated, will be this one. We're going to get a text as parameter. We're uppercase after just separating each letter with an underscore. So as you see, we have the decorator, in this case would be the snaker, and then we're going to have the uppercase function. The difference over here is that the wrapper will take arguments because this uppercase function is getting arguments. Therefore, these are the default arguments. Do not change it. These are specific keywords. And what we do is to list what does this function returns. Basically, these args are these ones. And then we iterate over the function while joining every character with an underscore, and then we just said okay, this is hard coded. And what does this with this snaker parameter will be first take the text, uppercase it, and then go onto this snaker function. If there is another decorator over it, okay, we can get nest more decorators. The order will be ascending, so we have this function, then a snaker, and then the next one, the next one, the next one, etc., and so on. Now let's get into all decorators in Python. The first one is property, and what it does is it just returns a property value, often used for getters methods. So if we have this Cipheros call that just gets a name as a parameter, well, if we want to get that name, we use this property decorator. By the way, these decorators are just built-in functions, okay? Just on the same way. Number 2, class method. So rather than self, it uses a CLS keyword. This is just another identifier. Now with a static method, it is basically the opposite because we don't use self or the CLS. So these are just for methods that do not do something with the attributes of the class. For example, a custom message if something went wrong. And from this instant on, we're going to import function tools. Jet, and this is a built-in library, okay, integrated already in Python. Therefore, this is technically built-in also. What does this is basically gives the metadata of the function. Let me explain you how this works. So if you remember this hello function is being passed to this myDecorator function, and this will be always on its declaration from this instant on because we have this add line. So normally if we print this hello dot underscore name underscore, but actually it will take is the name of this myDecorator because this hello is wrapped on myDecorator. Yes, because we have this 15 decorator one. You actually keep all the data from this hello function. Therefore, what is printed in rather than myDecorator is hello, because this is the metadata of the function. This is the next one, and what this does is catches the function's result as many times as we declare it, often used from recursive functions. I suppose that you know the Fibonacci sequence is basically a sequence of numbers. We start by 0 and 1, and the next number will be the sum of the two previous ones. We have this function. Over it, we set this decorator with a parameter of max size. Therefore, what it will do will be take the end because we'll return it, and then take this Fibonacci call and this Fibonacci call. Yet this will be not the first 3 one. We are actually getting a Fibonacci sequence of 10 numbers. Therefore, it will be the 8th number, the 9th number, and the 10th number. I don't remember it exactly, but here you have the 3 last between that first 10 ones. Similarly, we have functors caching, which is just the same thing, but the max size parameter is automatically set as none, so we don't have to pass any parameter over here. Every data of the function is already caching. Finally, we have single dispatch, also require import. Now what this does is runs the specified code depending on the first arg. So we can modify a function and on its code inside depending of what the type of the file is. The first definition will be for anything else, right? If the value is not an integer or a string. We modify this verifier with this decorator, which is take the name of the function and then register. So if the value is an integer, we'll display this, and if this is a string, we display this. I was thinking of what would be its utility if we already have the conditional statements, that is if, elif, and else. And there is a clear difference because conditional statements may not be that performant if they are too many in comparison to the single dispatch. Also, the code looks cleaner. Yep, single dispatch may be a little bit slower because it requires import and it is basically using another function inside this one. Yet for big projects, it's better to approach for this. So if we pass this verifier with an argument of 10, this will cause the interversion. That is, now that's a string and it will turn this 10 into a string. Similarly, if we pass this high, we're going to have a no, that's uppercase and over here. And this guy will be uppercase. Now, do not think that if you pass a boolean, for example, this will be for anything else, because this value int is actually being analyzed as a boolean. This 10 is true. It's a truthy value. It's a positive number different from 0. Therefore, this will be turned into true. And if this statement is that value is integer, this is true, this will be turned into that. If we want to pass specifically a boolean, we must declare another version of this verifier with value equal to boolean. I hope that this is understandable.
And that's it. You've now seen every Python feature that Fabrizio covered in these 3 videos. If you enjoyed this compilation and want more fast, clear programming tutorials, make sure to subscribe so you don't miss the next one. Pop a comment telling us which feature was your favorite, and share this video with a friend who's learning Python. Thanks for watching, and see you in the next one.